Okay, we are going to talk today about geometric sequences, arithmetic sequences, and series. We were adding a common difference. Geometric, we are multiplying by a common ratio, which could be a whole number, it could be a fraction, it could be any kind of decimal, it could be pi. Multiply by pi every time as we go down our sequence. Um, Please take the time to actually watch this video on how does radiocarbon dating work, and then we will move on. Okay, I'm not going to show it in this. So, geometric sequences. Um, in a geometric sequence, we have a common ratio. So, the ratio is always given by ratio, the current term divided by the previous term. You will see sometimes the recursive formula, u sub 1 equals whatever the first term is. And then the next term is just r times u sub n minus 1. Remember, this u sub n minus 1 means the previous term. Also, the explicit formula here, u sub n equals u sub 1 r to the power of n minus 1. Okay, so find the common ratio of the geometric sequence. Looks like I'm multiplying by -3. Let me pause for a second. Okay. Our second one here, we are multiplying by, no, we're not multiplying by the same thing. First one is multiplied by 2, then it's multiplied by 4, then it's multiplied by 4. That is not geometric. Okay. Guess I gotta clear these. Our third one here is multiplied by 1/4. 3 times 1/4 is 3/4. 3 times 3/4 times 3/4. No, but times 1/4. Equals 3/16. If you couldn't find it, you could do 3/16 divided by 3/4. That feels harder in this case. And then I'm cross-reducing here. Now I would need to check it for all of them. I can check that multiplying by 1/4 does work too. This one, my common ratio is I'm multiplying by x squared each time. A little bit different ratios, but we're multiplying by the same thing every time. Sorry for the interruptions. Back to this. A geometric sequence has a first term of 81 and a fourth term of 3. Find the common ratio. Okay, so what do I know? I know u sub 1 equals 81. I know u sub 4 equals 3. So I could use my geometric series, the recursive formula, or this explicit formula here. And that tells me that this was the formula. U sub 4 is equal to 3. U1 was 81. My ratio is unknown. It's my fourth term. Let's make that a little bit neater for. I'm going to divide both sides by 81, so I get 3/81 equals r to the third. 3/81 reduces to 1/27. I'll cube root both sides. And that gives me r of 1/3. So really, really helpful in most things in mathematics and life. I'm gonna make that neater, r. Most things in math, in this class and really math and life, getting equations down, getting your knowns and unknowns right here. I was looking for r. I suppose I could have wrote that down. Knowns and unknowns, getting equations and going from there. That's really key in this class. Show that the sequence with 3 consecutive terms is geometric. Well, I can test the common ratio. That one's 5. I'll take a calculator and check the other one. Also 5. So the common ratio is 5. So thus it is geometric. That's example 3. Example 4. A geometric sequence has a second term of 30 and a fifth term of 14, negative 468.75. So, again, get my knowns and unknowns down. U2 is 30. U5 is negative 468.75. Well, I can kind of cheat a little bit. I'm going to pretend like that's the first term in my general form. So here's my general form again. 30. Instead of this being the fifth, if I wanted to use negative 48.65, if I want to use, I can treat U2 like it's U1, and then U5 becomes like the fourth term. Okay. That just simplifies it a little bit for us. It's not the first term. We know it's the second, so we'll just have to deal with that later. We'll divide by 30, and that gives me r cubed equals negative 468.75. I get negative 125/8. When I cube root that, I get negative 5/2 equals r. That's my common ratio. My first term, well, I can either use the formula, or I can realize that my first term, U1 times my common ratio equals U2, which is 30. So to solve, I'm going to multiply, plugged in my 30, by negative 2/5 on both sides. 30 over 5 is 6 times negative 12. And that gives me a U1 equals negative 12. That was probably a little quicker. It is important to note that U1 times the common ratio is U2. U2 times the common ratio is U3. That shows up in some of these problems. Okay, example 5. A geometric term has a second term of 14 and a sixth term of 224. Find the possible values for the common ratio and the first term. Same idea again. Let's do this one in black. U2 equals 14. U6 equals 224. Find the possible values of the common ratio. This one's interesting because it's actually going to have two. Okay? So, not U2, U6. 224, it's now five terms instead of the sixth term. It's five terms after U2. So if I'm going to use U2 here, I've got to account for that. R to the 5 minus 1 is 4. I'll divide both sides by 14. That gives me 16 equals R to the fourth. I will fourth root both sides and I will get plus or minus 2 for R. Yes, it could be either of them. Because -2, you could go negative back to positive. It'll go negative back to positive for the first ones. Now, again, I know U1 times 2 equals 14, which is U2, or U1 times 2 equal times -2 equals 14. So U1 either equals positive or -7. Yes, there are two options depending on what that common ratio is. Okay. The general term of the sequence is given by U sub n equals 5 to the 3 minus 4n. Determine whether or not the sequence is geometric. So there's a few different ways to do this. You could start plugging them in. U sub n, or I'm going to try ripping this apart. $125 over this doesn't look quite geometric. Actually, maybe. It doesn't have the n minus 1, but yeah, this looks like something times a common ratio to the power of n. Yes, I could make my 125 meter. Definitely looks like this probably geometric. Another option to do this would be to just plug in 1 for n. So you end up with 5 times 3 minus 4 is 5 to the -1. Your next one is 5 to the 2. If I plug in 2, I get 3 minus 5, 5 to the -5. If I plug in 3, I get 5 times 3 minus 12 is 5 to the -9. If I plug in 4, you get 5 times 3 to the 3 times 4 to the negative 3 minus -13. each one of these is being multiplied by 5 to the negative fourth, which is 1 over 625. So yes, this is a geometric sequence, a slightly tricky one. They used a very interesting version of this. Oh, so they did n minus 1, did the previous term, if you see their version of it, proving they used n, plugged in n minus 1 in the formula and got that, which is 5 to the negative fourth. Okay. Last one. Given the sequence x minus 1, x plus 2, and 3x is geometric. Find the possible values of x. So I know that first term x minus 1 times some common ratio has to equal x plus 2. I also know x plus 2 times the same common ratio has to equal 3x. So right now here, I have two equations with two unknowns. xr minus r equals x plus 2. I'm going to subtract. No, let's not do that. R equals x plus 2 over x minus 1. And r also equals 3x over x plus 2. These two, both being equal to r, put them on the other side, can be made into a ratio. That's probably the easiest way to do this. And I'm going to cross multiply because I've got a nice equal sign between them. X plus 2 times x plus 2 is x squared plus 4x plus 4 equals 3x times x minus 1. I have to distribute 3x squared minus 3x. I'll set it equal to 0. I'm going to move everything to the right. Yes, I'm doing that to both sides. I just don't feel like writing it on both sides. 3x squared minus 7x, or 2x squared minus 7x minus 4. I think this factors 2x and x minus 4 plus 1. Yes. X equals negative 1/2 or 4. And yes, they agreed with me on how to set this up. So I did initially start in the wrong direction. I didn't really want to do this and try to make this. What I wanted to do was solve each one for R. That's one there, this one's here, and then I could set them equal to each other. And that gives me probably the quickest and easiest way to do this. Okay, 1.3.2 coming right up. Geometric series. Remember series, we add them all together. Okay, please take a second to watch the proof. You are not expected to do proofs on the IB exam, but understanding them is going to be some of the things that help you gain the understanding to get those higher grades. Okay. Both the formulas for the geometric sum for the first n terms are in the formula book. There's a couple of different formulas, and one that's really a kind of simplified version of the other. For geometric, the sum is the first one, no, R sub n minus 1 over R minus 1. If you look in the formula packet I gave you, I believe I have that reversed. It's just an extra negative on top and bottom, which cancels out. So it does not matter which way you use it. If you're talking about an infinite sum, which we'll get to later, 1 minus r to the n goes to 1, because r to the n goes to 0. If it converges, it goes to 0. If it does not converge, there is no infinite sum. So find the sum of the first 8 terms of the geometric sequence defined by this. Okay, so, this looks like pretty close to my general formula. So the first 8 terms, well, the first term is going to be, I actually have to plug in 1. It's not quite in that form, so I don't have u sub 1. But I can plug in 1 for n to the first power. That doesn't really do anything. So my 5's cancel. That reduces to 12 over 1 equals negative 12. Now find the sum of the first 8 terms. I'm going to use my sum formula. Negative 12, negative 5 halves to the 8th minus 1 all over negative 5 halves minus 1. I'm using the formula that they did. I go to my handy dandy calculator. And I type it all in. And I get like 163,000 over 8, or 5228.16. I got that on the calculator. And they round to what's known as 3 significant digits. We'll learn that in a few days. Interesting, they're talking about it in the book before it's taught. But, that's kind of how this goes sometimes. So, yes, we'll talk about the rounding coming up. So, another example. The sum of the first 10 terms is 1364. And the 2 consecutive terms are 32 and 64. Calculate the value of the first term. So here I know that S sub 10 equals 1,364. 2 consecutive terms, I don't know which 2 they are, but it does give me the ratio to be negative 2, as I can do negative 64 over 32, if it wasn't such an easy one. So I've got 1364 equals U1. I'm just going to use my formula. Negative 2 to the n minus 1 over negative 2 minus 1. So that's negative 3 on my denominator. And I'll multiply both sides by negative 3 to get it out of the way. And I get negative 4092. Oh, n here is 10. I know this. I don't have to be that. Oops, it erased too much. Negative 2 to the 10th. So then I've got negative 4092. U1, 2 to the power of 10 is 20 or 1024. 1024 minus 1 is 1023. So now I'm going to divide both sides by 1023. And I get, here, I'll do some different color. And I get this lovely number of negative 4. Oh, that was such a simple U1. Okay, so using my formulas, filling in what I know. Yes, I didn't initially recognize this 10 here. I put it in as an N. But I did know that somehow, oh, I've got the 10th term. I should be able to get that. So that helped me recognize, oh, I missed that. This is the 10th term and should be 10. Sometimes you'll be putting too many things in, you'll miss stuff. Hopefully you can catch it as you go through. Like, I should be able to solve this. Something's missing. Okay. Think about what you know when you get stuck. But that is the end of Monday.